we've talked a lot about convex lenses, so I thought I would do a quick video on concave lenses, although there aren't as many different combinations of what a concave lens can do. So just remember, concave has the word cave in it. So I always imagine that it's kind of caving inwards. Caving inwards. It's a little bit of an exaggerated drawing, but I think you get the general idea. This is a concave lens right over here. And let me draw its principal axis. So this is its principal axis. It shouldn't curve at the beginning. Let me just redraw it. So that's its principal axis. And let me draw the two focal points. Let me draw one over here on the left side, and then let equal distance a focal point on the right side. And I'm assuming that the two surfaces they're both concave and they're symmetric over here. That's just an assumption I'm making. Now let's think about what's going to happen if I put an object. If I put an object someplace on the left side of this concave lens. So I could put it, let me just stick it anywhere. So let me stick it right over there. So if I do, and like always, we'll do our two rays, but with the concave lens, what I'm going to do, I'm going to do two rays. I'm going to do one that's parallel to the principal axis, and then I'm going to do one that does not get diffracted. So it goes right through the center of the lens. And let's think about what happens. So if we go parallel to the principal axis, this will get diffracted in a way. Since it's coming in parallel, it'll get diffracted in a way. It'll get diffracted outwards so that it looks like it's coming from this focus. So it'll get diffracted in a way so it looks like it's coming from that focus. So it's getting diverged outward, I guess we could say. And let me draw another point, or another ray, I should say. Do that in yellow. And this one's just going to go straight through the center of the lens and not get diffracted. So it's just going to go straight through the center of the lens and not get diffracted. So what will the image be here? Well, clearly these two rays don't converge, so we won't have a real image. But they do both look like they're diverging from someplace, and they look like they're diverging. They look like they're diverging from right over there. So it'll look to an observer out here, if their eyeball is right over there. It'll look to an observer. I could draw their nose, just make it clear what the person, where the eye is. If they look at from this side, they're going to see a virtual image of the object right over here, just like that. So what you're actually going to see is a virtual image of the object that is not inverted, and it's going to be smaller. It's going to look like it's closer to the lens than it really is. Anyway, that's all there really is to know. I mean, there's a lot you can know about anything, but that's the general gist of a concave lens.